MSP430 is developed by Texas Instruments, and to know the detail about MSP430, you can refer this website of TI. MSP430 is specially designed for low power consumption embedded application. In most of the embedded applications, we require a less power. For example, in mobile phone, we required a more battery life. So that means we need a low power consumption of the processor, because processor is the main device in embedded application. So it is very important to consume a less power by the processor. It is also designed for low cost. So the requirement for battery operated portable product is increasing in all emerging fields. And since the heart of embedded system is processor, its power consumption is an important consideration. So this is the main feature of MSP430 controller or processor, that is low power consumption and low cost. The MSP stands for mixed signal processor. Mixed signal means you can give analog signal as an input to this processor, or you can give a digital signal to this processor. Actually, its name is mixed signal processor, but it is a controller. There is no clear-cut difference between processor and controller nowadays. So it is like a controller, because all the devices, most of the peripheral devices are available internally in this processor. So it is mixed signal processor because you can connect the analog signal as well as digital signal as a input. Internally, there are analog comparators, A to D converter. So when we give analog signal, the A to D converter will internally convert into digital, and then digital signal is processed by the CPU. The MSP430F5529, this is the example of one version of MSP430. So what this indicates, MSP is processor family, F is device type, 5 is series, and 529 indicate the feature set. Lot of versions of MSP430 and lot of families are available. In this lectures series, I am going to discuss about this particular family, MSP430F5529. Applications of MSP430. You can use MSP430 in almost all applications where there is a need of microcontroller. Just few applications are listed here, which are maintained in the TI website. The automation, factory automation, building automation, or home automation. For any type of automation application, you can use MSP430. Then in medical devices like glucometer, blood pressure meter, heart rate monitoring, this MSP430 can be used. In other applications also, we can use the MSP430. The features of MSP430, the general features are, it is C compiler friendly. That means we can write embedded C program for MSP430. And CC Studio is available to compile this MSP430 program, also to download it in the MSP430 board. So MSP430 boards are available by TI, and we can directly use it for the applications. This is a RISC architecture, reduced instruction set computer. There are 51 instructions, 7 addressing modes are there, and constant generator registers are there, so that we can store a 6 constant which can be used in the program. So that we'll discuss in detail. So it is RISC architecture. So size of almost all instruction is same, and also most of the instruction can be executed in one clock cycle. It is 16-bit RISC architecture. That means data bus size is 16-bit and 20-bit address lines are available. So we can interface 1 megabytes of memory to MSP430. That is 2 raised to power 20. Then single cycle register operation. So only one cycle is needed to operate on the register data. Then bit addressing, bit processing is possible, byte or word processing is also possible. 1 megabyte unified memory map because address bus size is of 20 bit. Extended addressing modes are available, which will improve the code density. Then faster execution of instruction is possible. 100% code compatible with earlier version. So any program can be executed in the previous version of this MSP430. Ultra low power consumption. This is the main feature of MSP430. 160 microampere, only 160 microampere current is consumed per MIPS. That is million instructions per second. In standby mode, the current consumption is only 2.5 microampere. Integrated low dropout regulator, brownout reset is available, watchdog timer is available, and RTC, that is real time clock, is also available. In the coming lectures, I'll discuss about all these circuits in detail. Then it operates on 12 megahertz frequency with a power supply of 1.8 volt. From the standby mode, it will wake up in less than 5 microseconds. Then increased performance depends upon the version. This processor operates on 25 megahertz frequency. The 1.8 volt ISP flash erase and write is also possible. So you can erase or write in a program memory at the voltage level of 1.8 volt. Fail-safe flexible clocking system is available. User-defined bootstrap loader is available. Then up to 1 megabyte linear memory addressing is also available. Innovative features, multi-channel DMA controller is available. So DMA controller is direct memory access. So without using CPU, we can transfer data from peripheral device to memory and from memory to peripheral device. So multi-channel DMA support is available. Industry leading code density. More design options are available, which includes USB interface, RF, encryption, LCD interface. These are the typical values given for the few versions of this MSP430. Supply voltage we can use from 1.8 volt to 3.6 volt. Current draw is nearly equal to 500 nanoampere in standby mode or less than 1 milliampere in operational mode. Wake up time is less than 1 millisecond from standby mode. RAM retention current is nearly equal to 100 nanoampere. Flash memory up to 512 kilobytes for this series 5XX and 6XX. RAM memory size is up to 66 kilobyte for 5XX and 6XX series. Bit depth is 8 bit, 16 bit or 32 bit. GPIO count is up to 90 pins. Other interfaces available are UART. Other interfaces available are UART, SPI, and I2C. Clock frequencies up to 25 megahertz for this 5XX to 6XX. For 5XX series and 6XX series. Packages available are DIP, QFP packages, and other packages are also available. MSP430 device consists of the important blocks like clock generator block, which generates a different clock signals, then CPU, central processing unit, ROM memory, E square PROM memory, data memory, that is RAM memory, peripheral models, and control unit, which generates a various control signals. Let us go through this general block diagram of MSP430. This is the clock system block. Clock system block generates three types of clock signal. Here you can see. The first clock is MCLK, which is a master clock signal. And this is the highest clock generated by this clock system. So this clock is connected to CPU. So CPU operates on this highest clock signal. The second is SMCLK, that is submaster clock signal. Submaster clock signal frequency is less than master clock signal, and this submaster clock signal is used for a watchdog timer and some faster peripheral devices. The third clock signal is ACLK, that is auxiliary clock signal, and this clock is the lowest of these three clock signal. This auxiliary clock is used for the slower peripheral devices. So clock system generates this three clock signal. Master clock is the highest clock. SMCLK, submaster clock, is middle clock, and auxiliary clock is lowest clock frequency. Here it is shown RISC CPU, and which is having a 16-bit ALU. So it can operate on the maximum 16-bit of data. It has a JTAG debug circuit, so we can download our program using JTAG connector. MSP430 has standard JTAG configuration. Then it has a flash memory or ROM memory. We can store a program in this memory. The OTP version of ROM is also available, that is one-time programmable. Then it has a RAM memory where we can store a data. Then lot of peripheral devices are shown here. It has a watchdog timer. Here it is shown auxiliary clock, SMCLK. Then peripheral devices. Few peripheral device may operate on SMCLK clock, that is faster peripheral devices, and slower peripheral devices operates on ACLK. Then it has memory address bus of 16-bit. So all these peripheral devices are connected through this address bus. Then it has memory data bus of 16-bit. The peripheral devices which are 16-bit size, they are connected to processor through this bus. If the peripheral devices are of 8-bit size, then there is a bus converter which converts this 16-bit data bus into 8-bit data bus, and then this bus is connected to peripheral devices. So this is the general block diagram of MSP430. Just go through the detailed block diagram of MSP430. Here the peripheral devices and ports of MSP430 are shown. So same blocks are there. Here this is the clock system which generates this three clock signal. Then there is a CPU, there is JTAG interface. Flash memory is shown here with different sizes, and this is the RAM memory. There is a power management block which is used for example for brownout reset circuit. Then there are watchdog timer. Then there is watchdog timer, and here the ports of MSP430 are shown. There are 4 ports of 16-bit size and 8 ports of 8-bit size. So here for this first block, 2 ports are shown, P1 and P2. These ports are 8-bit ports, P1, P2. Then second block is having 2 ports, P3, P4. Then third block, P5, P6, and fourth block is having port P7 and P8. So total 8 ports are there, and all these 8 ports are of 8-bit size. But if you want to use 16-bit port, then you can combine port P1 and P2 together, which is called as a port PA. Similarly, port P3 and P4 can be combined together to get a 16-bit port as PB. P5 and P6 can be combined to get a 16-bit port PC, and P7 and P8 can be combined to get a 16-bit port PD. Then there is a USB connector block. DMA controller block is there, direct memory access, which is having 3 channel. Then comparator block is there. Here reference block is shown. Then ADC block is shown here. These are the some serial peripheral interfaces, that is UART, IRDA, SPI. So serial protocol blocks are there. CRC16, CRC code generator, cyclic redundancy check. Then RTC underscore a real time clock. And these are the timers TA0, TA1, TA2, and TB0. All these blocks I'm going to explain in the lectures. Then MPY is hardware multiplier of size 32. Hardware multiplication is always faster than the software. So here there is a hardware block for multiplication. So these are the few peripherals which are available internally to this processor, and that's why it is like a controller. Just go through the important blocks of this block diagram. So we have seen the clock generator. There are 3 clock signals, MCLK, SMCLK, and ACLK. MCLK is master clock used by CPU, and it is faster compared to other clocks. SMCLK is submaster clock used by faster peripherals, and it is faster than ACLK. ACLK is an auxiliary clock used for slower peripherals, and it is slowest clock. Then CPU features, it has a RISC architecture with 27 instructions and 7 addressing modes. Orthogonal architecture with every instruction usable with every addressing mode. That means each instruction you can write in all addressing mode. So that type of architecture is called orthogonal architecture. Full register access including program counter, status register, and stack pointer. In other controller or processor, user don't have access of program counter, but here user can write or read a data in program counter register also. Single cycle register operation, to operate on register, you need only one clock cycle. Large 16-bit register file, since it is RISC architecture, more number of registers are there, so which reduces fetches to memory because data will be stored in the register itself. 16-bit address bus, which allows direct access and branching throughout entire memory range. 16-bit data bus allows direct manipulation of word-wide argument. On 16-bit data, you can directly operate. Constant generator is available, which provides 6 most used immediate values. So that we are going to discuss. Direct memory to memory transfer is possible. Direct, you can read a data from one memory location, process on it, and store it directly in the memory location. Word and byte addressing is also possible. Then code memory, program memory can be integrated as programmable EPROM or mask programmable ROM memory. Standard members will support OTP, that is one time programmable memory, and mask programmable version, that is ROM memory. The data memory is connected to CPU via 2 buses that we have seen, memory address bus, MAB, and memory data bus, that is MDB. So data memory can be integrated into a specific family member either with full word or with reduced bytes data width. So you can transmit or read 8-bit or 16-bit data from memory. So this is about the features of MSP430 and block diagram of MSP430 or architecture of MSP430. In next lecture, we will discuss about the different registers of MSP430.